How long does it take to reach each planet in the solar system? The time it takes to reach each planet in the solar system varies greatly depending on the planet's distance from Earth, the spacecraft's speed, and the trajectory used. In today's video, we're going on a journey to each planet starting from Earth. Ready to go? Mercury. Despite being the closest planet to Earth in terms of average distance, Mercury is surprisingly difficult to reach. This complexity stems largely from its proximity to the Sun and the intense gravitational pull the Sun exerts. The Sun's gravity is so strong that spacecraft heading towards Mercury need to significantly slow down to enter the planet's orbit, making missions to Mercury more challenging than those to some of the more distant planets. NASA's Messenger mission, launched in 2004, was the first probe to orbit Mercury, taking about 6.5 years to reach its destination. This time was much longer than expected considering Mercury's relative closeness to Earth. However, instead of taking a direct route, Messenger had to perform several gravity assist maneuvers around Venus and Earth. These maneuvers gradually slowed the probe down, preventing it from being captured by the Sun's gravity before reaching Mercury. These gravity assist maneuvers were crucial to the mission's success. By using the gravity of other planets, Messenger was able to reduce its speed without consuming large amounts of fuel. Although this technique lengthened the trip, it was essential for allowing the spacecraft to approach Mercury in a controlled manner, avoiding dangerous acceleration toward the Sun. Venus. Venus, the closest planet to Earth, is the second planet in the solar system, and is often referred to as Earth's twin, due to its similar size and composition. However, its surface conditions are extremely hostile, making missions to Venus challenging despite its relative proximity. Venus's dense atmosphere, composed mainly of carbon dioxide, creates a runaway greenhouse effect, causing surface temperatures to reach extreme levels, hot enough to melt lead. Space missions to Venus, such as the United States Mariner 2 and Japan's Akatsuki probe, took between 3 and 4 months to reach the planet. This travel time is relatively short, given that Venus is only about 41 million kilometers from Earth at its closest points. However, the fast journey contrasts with the difficulties faced when approaching the planet. Venus's thick and acidic atmosphere, made mostly of carbon dioxide with clouds of sulfuric acid, presents a major challenge for any spacecraft attempting to pass through it. One of the biggest complications in exploring Venus is precisely its atmosphere. The surface pressure is about 90 times greater than that on Earth, equivalent to the pressure found 900 meters below sea level here. This means that any equipment attempting to land on Venus must be extremely robust. Additionally, the planet's sulfuric acid clouds quickly corrode any unprotected metal or material, making the survival of probes on the surface short-lived. For example, the Soviet Venera probes that landed on Venus only operated for a few hours before being destroyed by the planet's extreme conditions. Mars. Mars is the fourth planet in the solar system, and, over the decades, has become one of the most popular destinations for space missions. Its relative proximity to Earth and the scientific interest in its conditions make Mars a constant target for probes and rovers. The travel time to Mars can vary between 6 and 9 months, depending on factors like the spacecraft's trajectory and speed. Recent missions, such as Curiosity in 2012 and Perseverance in 2021, followed this average travel time, taking advantage of favorable launch windows to minimize the distance traveled. These launch windows to Mars occur every 26 months, when Mars and Earth are in a position called opposition, meaning they are closest to each other in their orbits around the Sun. During these times, the distance between the two planets is reduced, allowing for a shorter and more fuel-efficient trip. If this window is missed, the next opportunity won't occur for another 2 years, making meticulous planning essential for mission success. This is why every mission to Mars is carefully synchronized with these rare opportunities. Mars is one of the most studied planets by probes and rovers due to its potential to have once harbored life. The presence of water and ice form, evidence of ancient rivers and oceans, and the geological composition make Mars a key candidate in the search for signs of past life. Jupiter, the largest planet in the solar system, is located much farther from Earth than the inner planets, making missions to it a significant logistical challenge. NASA's Galileo mission was one of the most important to study Jupiter up close, taking about 6 years to reach the planet after its launch in 1989. The average distance between Jupiter and Earth is about 778 million kilometers, requiring careful planning to ensure the spacecraft has enough fuel and an efficient trajectory to complete the journey. The duration of the mission is influenced not only by the distance, but also by the complexities of navigating the solar system. One of the key strategies for long-distance missions like this is the use of gravity assist. This technique involves using the gravity of other planets to slingshot the spacecraft, saving fuel and gaining speed without excessive use of thrusters. In the case of Galileo, it performed orbital maneuvers around Earth and Venus before heading to Jupiter, taking advantage of these planets' gravity to boost its speed. While this technique lengthens the total travel time, it is essential to make reaching distant destinations like Jupiter feasible. Saturn, the second largest planet in the solar system, is best known for its iconic and stunning rings. Located even farther from Earth than Jupiter, Saturn poses a significant challenge for space exploration due to its great distance, with an average of about 1.4 billion kilometers from Earth. NASA's Cassini mission, launched in 1997, was one of the most important for studying this gas giant and its surroundings. The probe took about 7 years to reach Saturn, arriving in 2004, and spent over a decade gathering valuable data about the planet, its rings, and its moons. In addition to its spectacular rings made of ice and rocks, Saturn is home to a fascinating system of moons, most notably Titan and Enceladus, which continue to attract the interest of scientists in future missions. Titan, Saturn's largest moon, is especially noteworthy for its thick atmosphere and liquid methane lakes, making it the only celestial body besides Earth known to have stable liquids on its surface. Uranus, the seventh planet in the solar system, is known as one of the ice giants due to its composition of mostly ice and gas. It is one of the most distant planets from Earth, and this, combined with its extreme environment, makes its space exploration a significant challenge. So far, only one probe, Voyager 2, has visited Uranus, in a historic flyby in 1986, after a 9-year journey following its launch in 1977. The mission provided the only detailed data set on the planet, but Uranus remains one of the least studied planets in the solar system. What makes Uranus particularly interesting is its strange tilt. The planet rotates on its side, with its axis tilted about 98 degrees relative to its orbital plane. This means that, unlike other planets with a more conventional rotation, Uranus rolls in its orbit, with its poles alternating long periods of light and darkness as the planet moves around the Sun. This unusual behavior is likely the result of a catastrophic collision with a large object early in the planet's history, leaving Uranus with this unique configuration. Neptune, the eighth and most distant planet in the solar system, is a fascinating ice giant and one of the most mysterious due to its great distance from Earth. The only probe to visit Neptune so far was Voyager 2, which completed a 12-year journey before flying by the planet in 1989. This historic mission provided the first detailed images of Neptune and its moons, revealing a dynamic world with extreme atmospheric conditions and a subtle ring system. Voyager 2 discovered that Triton, Neptune's moon, has geysers that expel plumes of frozen nitrogen, suggesting that the moon's interior remains active and may contain subsurface oceans. Pluto, dwarf planet. Located in the Kuiper Belt, a region filled with small icy bodies beyond Neptune, Pluto was first visited in 2015 by NASA's New Horizons probe. This historic mission provided the first detailed images of Pluto and its moons, completely transforming what we knew about this distant icy world. New Horizons' journey to Pluto took 9 years and 6 months, highlighting how remote this dwarf planet is from Earth. The probe revealed a surprisingly complex world with a varied surface, including ice mountains rising up to 3,500 meters and vast frozen plains like Sputnik Planum, made mostly of frozen nitrogen. These discoveries dispelled the notion that Pluto was a simple and inactive celestial body. Instead, its surface shows signs of relatively recent geological activity, something unexpected for such a distant and cold object. Now you know how long it would take to reach each of the planets in our solar system, based on missions that have been carried out to date. Each journey has its unique challenges, whether due to distance, gravity, or even the atmospheric conditions of the planets. I hope this information has helped you better understand the incredible journeys these spacecraft undertake in space. If you enjoyed this content, Don't forget to leave a like, subscribe to the channel for more universe curiosities, and share it with others who also love astronomy. See you in the next video.